So welcome to the third Genestack webinar dedicated to the metadata curation. And today we'll speak about why it's important and how it can be done in an automated way. So we will cover the urge for metadata curation. We'll be discussing how the reusable rules can be created based on the invalid patterns in data from different sources. And then we will be creating some of the example study and looking in details into the rules and cover also some advanced curation cases which are available there in Open Data Manager. In the very end, there will be a Q&A session, but please put the question in the chat box wherever they pop up, and we will answer them in the end of the session. So why it's important to harmonize the data, right? And why do you need it? First of all, data, of course, is nothing without the context. So if you have some data, but you don't know from what species this data is, how it was gathered, unfortunately, you cannot get any use of this data, right? Also, even if you have some metadata and some description for data captured in any way, it's still very hard to find the data relevant for you in case each and every study is captured in a different manner. So curated metadata helps you in effective search of any data available. And you can easily not only find it, but also you can efficiently reuse it. And as my colleague Tima amusingly described in our previous webinar, without harmonizing curated data, you cannot get any effective machine learning because of the principle garbage in, garbage out. So our intention is, of course, aligned with the data verification, right? To have data in one place, accessible and interoperable and reusable. And for these purposes, you've got to have your data harmonized. This is something that's pretty agreed among the industry, but just why we do still have our data messy then? First of all, there is a huge amount of data and it's growing all the time. But then also there is the simple part that describing the data and filling all these little fields is a pretty boring process, and no one really quite eager to do this instead of doing some researches and insights. Other than that, so sometimes data can come from public resources, and it could be captured in any way, which is not really aligned on what you are used to and agreed within your organization. Also, you can, in some cases, get data from different CROs. And as well, even very good, nicely described data can just be captured in different terms. And that will really make any kind of search much harder. And even if we're not speaking about the CROs, even within the same organization, different department, or just two different people, they will still naturally will describe things in a little bit different ways. So what can we do to this? In the first webinar, we discussed in more details the solution that we came up with for providing a tool for creating metadata. And the idea is that we do have this minimal metadata model, and we have templates. This helps us in identifying any inconsistency. So first of all, you're defining some rules, some expected attributes, and the way of expected metadata. And then the system helps you to detect those problems. And in case there is something wrong, you can replace it, or you can find what's missing. And now I would suggest to just switch to some example study that I loaded today prior to the webinar. And there are lots of different fields, right, that came. But also I created just like simple template with some list of fields which we supposed to be expecting. And as you can see, some of the metadata here isn't valid, and I'm immediately notified by the system that something is wrong. In this specific case, for the attribute organism, there are values human, but it's actually not the preferred label for the dictionary, and I set the dictionary to be NCBI taxonomy for checking any values entered into the attribute organism. Also, the attribute sex is set to be filled, but it's empty. And there is some problem with disease, but again, it's just not because the information is missing, but it's just entered in some different way. Also, if we have a look here, so I have some other fields that could be optional, but still could be pretty helpful, and they also empty. But actually, I do have this kind of data, but again, under the different names. So if I just want to create one study, I can do it here. So what I can do, I can just directly in the browser, I can just click on it and say that I want to replace my values. And in this specific case, actually the whole problem is just because of the cases, right? So if I just go there to rheumatoid arthritis here, and I can replace those values, and almost immediately I can see that everything is nice and clean. The other example could be, for example, tissue. It's missing here. And I'm pretty sure that there was some information among all these multiple fields regarding the tissue and cell type. So those are all the fields from the original source which were there. So, okay, for example, I can just I can reassign this attribute and say, okay, that's good. Just in my template, that's called tissue. So let's just put those values there. And now I can see them. I can see them here. It's still the thing that they are not from the Oberon anatomical entities, but this is something that can be fixed later on. But the overall idea that it's very handy and pretty nice if I want to do this just in this study. But what if I'm about to load 100 studies or 1,000 of studies from the and I will have to do the very same operations multiple times, and that's any repeatedly manual operation, they're error prone, right? And also they're pretty time consuming and could be exhausting. So that's why we do have a way to do it automatically, to do it via creating the special rules. Oh, sorry. So how it can be done? Actually, first of all, what can be configured? It's the very similar thing that I just demonstrated in the browser, but you can just describe it and the system will do it for you. So first of all, it's reassigning values from one column to another. It's either can be done when you just imported your files from some other source, or maybe later on you decided within your with your colleagues that you want to have a different name, and in this case, for some of the entities you are capturing, that happens sometimes. We tend to change and improve our terminology. So in this case, you then can just rename this attribute for all studies which have already been loaded into the system. The next thing is that you can specify very specific value-to-value mapping. Just say that, okay, change all those values to these very specific values. This is what I did for all the rheumatoid arthritis values. But sometimes, if you don't want to do it kind of like to describe each very specific mapping, you can just say, okay, just take this dictionary and find the synonyms and please replace it with the preferred label. So you just apply the dictionary, and the system will read the dictionary and choose the preferred label. So how we describe the rules. So the very so this is just a JSON file where there will be some required and mandatory objects. Like if you want to apply curation, first of all, you should say to which entity it's applied within the system. So we were working now with samples, right? With samples. So in our example right now, for all our rules, the object type will be sample. Then also you should specify, you must specify the row keys. So what was the original or the previous name of the attribute which is considered. And the Genestack key is actually the name of attributes that you want the value to be captured after your curation procedure. Then optional again, we can either specify a value-to-value mapping, or you can specify a dictionary. So how it really looks like, I have here a few. This is very small example, right? Hopefully just small just because of amount of rules, but not in terms of the size, and you can see it well. So this is exactly what we discussed. So what I want to do, I want to fix 2 more columns here. So that's why I'm saying that for my samples, please, for the key organism, use the NCBI taxonomy to replace the values with the preferred label. And actually, for attribute sex, there were some values, but they were captured under attribute gender. And if we just scroll a bit and check it up, so okay, so this is attribute gender, and so also just in case. In this case, they're defined pretty well, but maybe not in all my studies. They would be very beautiful. So I also ask to rely on the dictionary, and in case there are some other ways of describing the gender, we can just replace it with the preferred values. So this is how the pretty simple rules constructed, and let's just see how we can do it. So we will just run the script right now. It could take some time, so let's just run it, and then we will go through the specific cases of like what exactly it means what there. So right now I'm just copying the accession of my study because I want this specific study to be created at the moment. And here I got some command that I will be just showing you. So I'm running my script just from the terminal. So basically, this is the name of the script. I also get to be authorized. I've got to have specifying the server and the template. And right now, the automated curation task is started. If we will look at this in more details, so this is just the list of parameters. Of course, you've got to specify on what study got to be created. And if you have a bunch of studies, what you need to provide list of accessions or IDs separated by commas, and like you can run curation of 10 or like 100 study in a row. And they all will be doing parallel. Also, since in our system, there is possibility to have multiple different templates, right? For example, for different department or for different type of studies, and potentially different set of attributes can be, and different ontologies and dictionaries can be used. So that's why when you run in this script, we also ask you to specify the template accession. Otherwise, the default will be used. There is a possibility if you not feeling comfortable to run the script on a bunch of studies on your product environment, and you might first thinking, okay, am I sure that my rules are correct and that I captured everything right and it will work in the end, or how many values will be replaced? So in this case, you can just first start the script in dry run, and just will see the logs information of what has been changed and replaced. So this is a way of doing it. And after that, if you're satisfied with it, you can run the script without this parameter. Also, there is another way of kind of protecting the original data. So sometimes if you're not just reassigning values to an empty attribute, but there actually was something there, and you do not want to overwrite anything to ensure that nothing is lost and all the data that was there originally still available, you can just skip this parameter and nothing will be overwritten and all the data will be saved. Yeah, then of course, if you do have rules, you should specify where your rules are captured. And there's also, of course, some help describing all these parameters, the way how to work with the script. Okay, so once actually this is started, the task is started, you can go back into browser, and there this is the tasks. Actually, this link is available from any page of Open Data Manager, so you can view all of the tasks. And yeah, you can also see a bunch of other automation curation tasks that I started. So this one is still running. That's probably because of the amount of samples there, but anyway, you can view the logs here. If something went wrong, you will have some information here. So for now, all is fine, and we just have it in process. Meanwhile, if we would go back to the to our study, and we will just refresh the page, you can see that that actually some values have already been changed, right? And we can see that out of kind of 2,500 of samples, for example, more than half was actually already replaced from being human to Homo sapiens, because this is the preferred label. And same here, kind of most of values have already been filled with either female or male option. As you can probably see, so there it also was using the uppercase, right? And now it's always a lowercase. And this green color means that it's those values, they are consistent with the selected terminology from our ontologies used. So this is one example of what can be done. The main thing here is that why it's so of course you've got to spend some time, right, for creating these rules and just thinking of, okay, what is wrong and how it can be fixed. But if you get multiple studies, you can create those rules just one and then run it. Also, if you have studies coming from the very same source, let's say once a month or like twice a week, you can just gradually add more and more specific rules or more and more different kind of typos or variations of the same terms. And you will have in the end not just such a small JSON file, but a bunch of pretty useful and frequently used rules, which can be run on almost any study. This is one way of doing it. So you can just gradually, while you're working with your data, work on the enrichment on the rules. And another case is actually that what we see here in the invalid metadata, when there is information like what is not from the preferred ontologies and like what is missing, etc., the very same validation summary is also available in Open Data Manager from our APIs. it's called the same, like validation summary. And you can just run this endpoint, call this endpoint for your data. And based on the response, you can configure the rules which will effectively work for your studies. Okay, so what I also wanted to cover, these are just a few more hints, like because these webinars, they are for users of who both kind of just started working with Open Data Manager or just eager to start and want to know more about it, and also for the kind of pretty advanced user, but just I added few hints how to get all these things which is needed to be able to run the script. This is a few details of how you can generate your IPA token, which will help you in authorizing when you're running the script. And also here, just a hint of how you can get the accession of your study, right? So you can do it how we did it in directly when you're reviewing the study in metadata editor application, or what you also can do, you can just do it from study browser. So this is the list of studies. You can just click here and copy accession and run a script on it.
Maria, and while you're still there in Open Data Manager, we have a really great question in the chat. So it says,
Sure.
Do you have data version control in case something goes wrong and we need to go back? So could you show it right now, maybe?
Yeah, actually, the thing is that data control is the topic for the next webinar. So I'll be just describing it in a like more detailed manner. But of course, we do have. So because right now, if we will go back, so when I opened my study, here there is information that there was an initial version, right? So and which was created when the data was imported to the system. You always can browse it and see. There is also the version which has been there after like my first edition, first rearrangement of the data, right? But all the changes which are done right now by the script, they are still saved just to draft. So I can open it, and actually now our task is fully done, and now it's ready and all our values are replaced. So basically what I can do, I can check that I'm almost happy with what is there. Okay, maybe just let me, I think we need to refresh the page to make it, to make all our filters work properly. So the changes are saved just to the draft version, which I can go using the edit mode. And now let's just recalculate it. So now everything is correctly replaced upon my rules. And once I'm happy with it, I can publish my changes and say that automated curation applied and reviewed. That could be actually any kind of information you want to. You also might want to publish changes without this manual check. So there is a way to provide a optional parameter to script that, like, please directly after this after changing the values, publish it straight away. And you can also provide what kind of message you want to be saved. But basically, this is the way. Now the system is just checking everything. So the version is published. And now my changes are available for all users within the system. They're also available via APIs. And the new version here, which I just published, is displayed. So yeah, but we will speak about it more. So anyway, if you're not happy with what has been changed, you can go to initial version, for example, and restore it. So, and this will be the actual information. We intended to try to be there in about like half an hour, to not bore you too much with lots of information. but I still wanted to show you one like pretty interesting case, or at least it can be helpful sometimes. Before this, just information how you can find the accession template. This is just a little instruction that you're always able to, by clicking on the study name, seeing what template is used. So this is some webinar, some template that I prepared for webinar. And in any time you can explore it. You can see the list of values here and what dictionaries are selected to be used. And yes, and then you can just click on it and copy the accession. And about the pretty helpful case, this is like, what if you have some values which is captured in the original source just as one value for one attribute, but you really want to split them to be able to kind of to compare the values there. So I think that DOS with units or town with units are the most relevant example here, because it's like the most frequent, right? So this is also something that can be defined by the rules. So in graphical user interface, so directly from the browser, you can't do it that wise. You can just copy or assign it, but using the script, you can split them. Again, it's not like that maybe wise. So what is using is just the very first white space or space, and that's how it will be changed. So in case they all, I mean the key and the unit are not separated at all, they will be just saved in one cell. But in other cases, it's pretty helpful. And so for this, I've got like really small little rule. So this is how it's captured. The same, you just say that, okay, this is samples, and please take one row key. So this is only one attribute, age, years. But then in the Genestack key, I just provided two of those different attributes. So basically what I'll be doing, I'll just do the very same, because all the information is the same, my token is the same. The only difference here is that the number of my rule files, right? So it's rules number 2 in this case. And so my automation rule is, my automation task is started. So now, as you can see, another one is started. By the way, I created few runs which were failed, just to show you that in case it's failed, you usually can just go, you can track it, and here you have pretty user-friendly information that the very specific study I tried it was using a different template, so that's why no curation have been applied, right? Because we want to be sure that we're doing only those changes that users are supposed to be doing. In this case, we just ask user to like check the template and run the script. So yes, that's pretty all. Just as a summary, being able to create your data automatically is really much easier, and saving you a lot of time, which can be used for more interesting tasks, and which can open like the whole power of your data. So we can maybe, if there are some questions, some other questions, we can discuss them, and then just in a few minutes check our progress on my very last run of the curation script.
Yes, thank you, Maria. Not a question right now, but a question that we got asked a lot. So could you show how the template looks like from the perspective of ontologies and dictionaries attached to it? So for example, to create a new field in the template and stuff like that, that would be really helpful, I think.
Okay, yes, of course, it's it can be shown. So let's just go to the very same kind of test template that I created, right? So for example, I can add here some kind of new field. Let's say let me just come test attribute. And if I just edit it at the moment, right, and what I can do, I can go to my my study, and if I will just update the page, all the attributes which came from the template, they displayed in yellow, and this attribute immediately applied. So this is just to demonstrate that any changes which are made to template, they are just like, they applied on the fly. You don't have to ask developers to do something, or just like go some deeper into configuration. So then when you just edit an attribute, what you can do, you can specify, would you think that this is a required attribute or not? If yes, the system will notify users in case the attribute is empty. Also, there are ways to specify what type of data you want there. Could it be just any kind of text, or you expect that this is just decimal or date? It also can be specified as external link, and this will be a clickable link which can help you to navigate to some, for example, raw data where it's stored, etc. Also, in case, mostly for the some technical attributes like ID accessions and maybe ID from original source, it's possible to make attribute read-only. That means that neither user, neither the curation script will be able to change the value. So yeah, but for most cases, they're not read-only. And here, actually, this is the dictionary column, the most like interesting part, because here you will see the whole list of all dictionaries and ontologies, which are available. In this case, those are the lists which are available on our test server. But of course, if you have some custom ontologies or you're using another one, you always can upload your own dictionaries or ontologies. All the most common formats are supported, and then you can just use them. Once you select it, for example, let's just put there, okay, just any ontology. Also, what you can do, you can, for any attribute, put a bit of description here, just to let users know what to be expected to enter here, right? So this is just testing, adding new attribute. So later on, if I will go back to my study, and let's just again replace it, we can go to the edit mode, and we can see that this test attribute, and on hover, I can see the tooltip which I entered, right? So once the user will be working with it, they will be able to understand either what to enter or what are values there. And now, if I click on it, the values here are actually, they are from ontology that I selected. And if I will put in anything which is not from the ontology, again, it will be highlighted. So okay, maybe that's yeah, it needs a bit of a time to understand it, yeah, because I was still focused this cell. But yeah, it's immediately kind of validated and notify the user that it's kind of not a preferred label from this ontology. Okay, at that time, actually, what we can see that the values that were in this age and HERs column, not from template, right? They are now successfully changed here as a split. The only thing here that this curation script, so originally the values were saved as strings because they were both kind of number and some string value, right? And that's why now I have this notification that they're not decimals, but for this purpose, just what can be done, you can just click on this convert value types, and the system will check if there is or there are any values that are actually integer or decimals, which are stored as strings. So if you just, this can be easily converted and you've got all your values right. Okay, is there any other questions?
Yes, actually, I think we have one. So it's about the raw data. And so the question is, do you have association information with raw data and file location, where the raw data is stored, and how to access the raw data in high throughput way using bioinformatic pipeline? I think that's a really good question.
Oh,
So
yeah.
I know, yeah, we get asked it a lot. So I think we could just go ahead and show the some examples where we store raw data as links. I don't know the exact study that we have, but maybe I can help you look it up, because we don't have raw data for all the studies. We
Yes,
have for
yes, of course.
some. So yes, I will
But
just
yeah, if
go
you
ahead and
can
search for it.
assist and send me the link, that would be helpful. Just in the meantime, the idea is that we so everything that is loaded directly here, I mean, like the information of the sample description, right? Or for example, here this is the expression file with some expression values. So these things, the process data, of course, and normalized. So this kind of information we index in, and it became immediately searchable via our both graphical user interface and APIs, right? But for raw data, you're not searching by by the values in FASTQ files, so that's why we're not loading them, because it will be they just pretty big in terms of size, right? And usually there's no sense to kind of store them in case they are not indexed. So usually they can be stored either in your storage, or we can store them in associated S3 bucket, which will be kind of automatically link, and the link to the location of file either to our S3 bucket or to your any kind of storage. It can be captured just the another attribute. So, okay, this for this specific.
Yes, so I have sent in the chat in Zoom.
Okay, good.
The link, you can just follow it, and it's under sample.
Okay, yeah, perfect.
It's under sample supplementary file. We have txt.gz files. Those are all files there.
Thank you so much for assistance. So yes, so this is some other study, right? And this using another template, and there's another
It's the
set of
very end
fields.
of it.
Sorry?
It's at the very end of it, because we applied the wrong template, so it's
okay.
somewhere in the end. Yes.
Yes.
Oh,
So anyway, so even if the values are not from template, they also indexed, right? So this is all also searchable, and there is information and a link where the file stored. So this is one of the way to track the raw files. Actually, the very same thing. So also could be a way for storing imaging data, for example. Yeah, as the part of metadata as a clickable and link, which can be used and reused. Yeah,
yes, I think that's
thank you for the question. Yes, hopefully you spend your time with some excitement and enjoyed our webinar. In any case, you're welcome to rewatch the video recording in case you would like to see more details. So thank you so much for attending, and please come to our next webinar when we will be speaking about tracking all the versions of generated data and metadata. It will be in the last Wednesday of May. Thank you.
Yes, that's great. So thank you, everyone.
Bye.
Bye.